Okay, so we're gonna get started. Um, so I've been thinking about if there's like an end goal for things here, or if like I should be like having like there's a project or something at the end. And I think that'd be cool. And I think it would fit with sort of the thing, or like the idea with the lab thing or whatever. And I think there should be sort of an end goal here. So I'm thinking that it'll be something. I mean, I don't have it like set in stone. I was just thinking about it this morning. That it'll be something like you find a data set and just do some pretty preliminary sort of exploration and maybe some, implementing some of the visualizations. And then if we get to regression, maybe doing something with that. But I don't know if that's maybe a little. I think that's feasible if we get to regression. So and we'll probably get to that if we'll probably get to that next week or the week after. Um, I I feel like we have time, so I think we'll get to regression. So maybe have that be part of it. Just kind of finding a data set that you're interested in would be really cool, and then doing some sick stuff. And I would be available to help you find something. If you want to just ask me, I kind of want something like this, and we could maybe talk about where we could find something like that. Um, Kaggle is a really cool site. I don't know if you've ever been on there. You've got a lot of really cool data sets. That's where I found the Brexit one. So there are websites out there. You can go on GitHub. New York Times has COVID data. So does YouGov if you want to do something timely. Um, there's a lot of resources, so we can kind of work on that and kind of if I can help you with that if need be. Um, so yeah, that's kind of what I'm thinking. It wouldn't be crazy. It would maybe just be like maybe the situation is like, people are, there's this firm or whatever asking you to kind of do an explore, or like you're, wanting to do some preliminary research or, look at getting some quantitative backing for whatever paper you're writing, since it is an empirics class that this is attached to. So maybe you're wanting to do some research, write a paper, um, do sort of the preliminary quantitative stuff to sort of back up something. Um, I think that could be cool. So that's kind of what I'm thinking. Hope that sounds good to everyone. I think that's kind of a good end goal for all of these things, and we can kind of put together all these skills, um, and for you to work on your own sort of data set would be cool. So, but yeah, now that that's sort of out of the way, anyone have questions about that? I mean, I'll probably have it be due whenever the last day of classes are. And again, this thing is pass fail or whatever, so I don't think it's very high pressure. It'd just be kind of something to kind of end this out. I think that'd be cool. So, and I again would be super willing to help with whatever. So I hope that sounds good to everyone. Um, Today we're just gonna kind of go over some of the other. Yeah, sweet. Yeah, election data is cool. Election data is really cool. So today I was thinking I've got some graphs that I have that I've made for other stuff. Um, and I was just thinking it would be cool to maybe look at them and think about how I made them. Like look at the graph first, because a lot of times when you're trying to visualize stuff, you have the data, you have the story you kind of want to tell, right, with the data. Um, and it's just about showing it in a nice way and like showing it in a way that communicates. There's a really good book called The Language of Visualization, or it's something like that. And it's like someone who was like one of the originators of tidyverse and like the ggplot stuff, and really good book, highly recommend. But it's kind of using these visualizations as a communication tool and thinking about it in that context, I think is worthwhile. So I was thinking we'd look at some graphs and we get some audience participation, and we'd say, based on what we know about ggplot and kind of how it works, we can maybe talk about like where these things are coming from. I've just got a couple. Can maybe find another one. too. But yeah, I think that would be cool. I think that would be valuable. So I'm not just talking at you. Um, so yeah, let's do it. Let's do it. Um, okay, so we got, you all see that? I think you can see it.
Yes.
So, so does someone want to volunteer and maybe tell me about this graph, I guess?
Can you zoom in on the graph, please?
Yeah. Yeah, I was just thinking I could do that.
My glasses can only do so much.
Whoa.
Ah,
Graph one. So, kind of maybe talk about what's going on here. There are labels. It's supposed to be clear. So, but so we want to talk about what's going on here.
I can give it a shot. So,
Oh, feel free.
this
Yeah.
is a density graph
Right.
of
The
three
y-axis.
different years.
Uh-huh.
Yeah. The renewable energy consumption as a percent of total final energy consumption.
Hmm.
For 3 different years. This data is from the World Development Indicators.
So how would we do this sort of like code wise? Like what like how are we gonna
Uh,
make this work, I guess?
so it'd be like ggplot and then data equals the whatever the data is called. And then the x would be, but then it'd be AES parenthetical x equals whatever the variable is called for renewable energy consumption as a
Hmm.
percentage of the total final energy consumption. Um, and then it would be hmm, color equals year or color and pattern equals year. I don't know
Yeah. So yeah, so
how
that's
you
kind of
get the
the
different
part of
patterns.
this I'm trying to highlight, I guess. Yeah, I got the code here. So this is the code for it here. Yeah, so we use geometline density, right? I think I recreated this with different colors. Oh no. Oh, I didn't bring in the data, that's why. Um, so it just looks a little different. I think I did it with different colors. This is like an assignment I did over the summer. So yeah, so we're setting color to equal, you know, the factor year, and then also the line type. And we're going to see later that I could have changed the color by manually putting in what colors I wanted. So yeah, so kind of showing how different densities vary across different years is cool. I think that's something that tells a story, kind of tells, um, communicates probably the trend that we were seeing in the data, when we were kind of doing our exploratory analysis, which we can kind of do with the sort of tidyverse thing or the sort of dplyr manipulation of the data, filtering, selecting, looking at particular data points. But also, I mean, maybe we were just thinking it would be cool if we saw if these densities are different. We can run statistical tests on this now to see if it's significant how different they are, if it's just up to random variation, right? So thinking about visualization as an exploratory tool as well is also something I'll point out. And then see here, I edit the y limit to be 0.03, like we talked about before. I know that was a point of like question before, so I thought I'd point that out. So it kind of looks different if we change the scale. We can do 1.5, and you see it kind of goes up. Um, so yeah, it's pretty cool. Um, can y'all still hear me?
Yeah, I was gonna ask it.
Okay.
Well, you just got rid of the graph. So it's the density of countries with that percentage of their energy makeup
Yeah,
coming from
so
renewables.
we've got, I mean, the variable is a little less important than kind of, I mean, that's not really what I'm trying to highlight, but I think it's,
Yeah, I know. I'm just trying to
no, I
understand.
guess that is a question about that. Yeah, sorry. Yeah, so it's the proportion of the distribution of the variable that has a value at a given x point,
Thank you.
right, on the x-axis. And this variable is renewable energy consumption as a percentage of total final energy consumption. So the percentage of total energy that you're using, that's renewable energy. And so we'd say there's like 19% at like 9% or something, or 8, 7 to 8. So it makes sense.
Trend does not look good.
Yeah. Right. This is higher. But yeah, so cool. Okay. Let's look at a different one. So we didn't do bar graphs. This is a pretty simple one. I guess I can just kind of talk through this. So when you're doing survey data, a lot of times it's really useful to see what this is a histogram, I think, actually. Yeah, no, it's a histogram. So it's showing the distribution. It's not really over time or from 0 to 1, but so a lot of times with survey questions, it's not entirely clear to the computer what not too happy means, what pretty happy means, what very happy means, right? So a lot of times you have to order these things. Let's see. This is a lab I did the other week. Just kind of stealing this. So you got to order these factors, and we could probably, I think we've gone over that, but I think I could probably go over that more because it can be kind of confusing. Because a factor is what, an ordinal variable you guys have probably talked about in the main 301 class, is an ordered variable, right? So he's probably brought up the example of survey questions. It's very common, especially in political science, especially in this, social sciences, that we send out surveys and they, say there's some scale. I'm, warm, I feel warm about this versus cold, or, favorable versus not favorable, right? But it's not always clear how we translate that numerically, and it's how we sort of reckon with that. So here, I gotta find exactly where I did this. So, all right, here we go. All right, here's a different thing. Let's make a new script. Oh, look at that, I've got a new one. And I'll show you. I'll kind of go over this because this is kind of important with plotting. So, so this is the general social survey data. It's got a bunch of, let's view it. It's got a bunch of stuff. It's just like a general survey. I think, what's the polling firm? Why am I blanking on the name?
Public policy polling.
Not Gallup. No. Why am I blanking on this name? I feel okay. It's fine. Survey done for a lot of people. We got a lot of years going on. Ranges from 1972 all the way to 2018. Pew, yeah, that's it. I think this is Pew. So we've got political party affiliation, right? And so what's really cool, we can go, and it's really sort of a useful tool is looking at levels, and that's if it's a factor, right? So if factor, right? Or unique. If not factor, right? So what these do is, so levels, if it's a factor, it has levels, or it's got a set number of values that it can take on. If we go back to this example, it's not too happy, pretty happy, and very happy. So if I think it's called, what's the variable called? General happiness. So another, and I've kind of talked about it before, using type of. So if we type of general happiness, oh no. So it's a character, right? So it's not a factor. So we can type in unique GSS $ general happiness, and it gives us all of the unique values of this, right? So the difference between the two, you might be asking, well, why do we care if it's a factor then? If it's a factor, there's an order to it. So like here, there's like a logical or like practical order to it. Or if we were looking at something where it was like, I strongly agree, I moderately agree, I neither agree nor disagree, you know, there's sort of a scale there. It's a scale, you know, from some value to some other value. And some, you know, the difference between very, very supportive and kind of supportive is different than the difference between very supportive and not supportive at all, right? Does that kind of make sense to everyone? So, you know, and visualizing this is important because we're looking from kind of left to right. It kind of is logical to look from left to right and say, oh, well, you know, and kind of like how Stephen pointed out here, I mean, this is numbers, right? But imagine if this was some character variable and this trend was not so good, and we're like, this doesn't really look good. But if it was out of order, or if we were like, you know, at least, you know, more people are very happy than not too happy. It would maybe not be entirely clear if not too happy was in the middle, pretty happy was over here. You know what I mean? You kind of see what I'm saying there? Like if these were out of order, out of some logical order, it would be less clear to the person you're trying to present to what's going on. So, you know, kind of being clear about that and ordering these things is really important when we're doing that, especially when we're looking at distributions of factored variables. So what we can do is, you know, and we've talked about it before, is casting something, right? So we use as.factor. And that's how we do. So there are a lot of different things we can do with this as. So as character, as, you know, there's a whole ton of things we can cast things as. But the really important one is as factor, or as numeric. And I've used that before, or as character. Those are the sort of big three, because numeric is numbers, right? You're saying, I want to interpret this vector as numbers. You can interpret it as character or as text, right? Or we're interpreting it as an ordered factor. And that sort of goes back to the continuous variables. You talked about types of variables in the Dr. Peterson has talked about that. So let's make an example vector here. This is kind of getting into something I didn't think we were going to get into, but this is good. This is good. Right. So we have, you know, X, kind of our basic thing where, well, I should probably copy that I might put this up. So good to save it, I guess. So X. Right, so if we wanted to save X as dot character X, so by doing this, I'm saving X, which we declared up here as a string of numbers, right? And we can make sure that it's a string of numbers by typing type of X. It responds double, but double is just another word for numbers to R. So we can say, I want this to be a character. And then when we run type of, right? Oh, wait. Gotta put X in there. It's a character now, right? So we're changing the type, right? And you'll notice up in the top right here, it's got quotes, or they've got quotes around the numerals, and it's interpreting now those numerals as characters, or like, you know, the character 1, you know, it's not interpreting it as the actual value of 1. Right. Does that kind of make sense? Does that difference kind of make sense? Okay, yeah. So then if we wanted to do the same thing, but save X as a factor, that's great, right? You know, and And then if we look at the levels of x, that's great, because so this is the order that they're in: 1, 2, 3, 4, and 5, which makes sense logically, right? Because that's how the numbers go, I'm pretty sure. You know what I mean? But let's say, all of the data isn't gonna be like that. So let's say it goes 5, 2, 4, 1, 3, right? So now we have, I've overwritten x. So now x is back to numbers, but we're gonna do, this might not work out actually how I want it to. As dot factor x, and then we look at the levels of x. Oh, I did it. Oh no, that's not what I wanted to do. Damn it. Okay. Okay. So it's not always gonna work out really cute like that, where it's in order. I think if we look at the levels of as dot factor GSS, it'll interpret numbers right a lot of the time. What I'm trying to get at is we can set the factors manually by using the factor function here, right? So we're doing as dot factor, but there I'm just leaving it up to R to interpret what the order of the factor, or what the factor level order is. But what I can do instead is go, I want a factor, and it takes in x, which is a vector of data, right? And then it can also take in levels. So I can go x equals x, right? Because that's the vector that I'm looking at. And then I can also manually type in levels. Let's say we wanted it to be in the opposite order. And then, so whatever order then levels takes in a vector, right? And I can put the numbers to be in order of whatever I want, right? Does that make sense? Does that make sense to everyone? Kind of how it's like I'm taking some vector of integers and I'm able to determine the order based on what I want. So I can set it in opposite order if I wanted to. And then I look at the levels of x, and it's opposite. It's 5, 4, 3, 2, 1. R is too smart for me to give it this dumb example, and it interprets the numbers correctly. But not always with the text, because I run into this a lot with survey data. It'll be all of the sort of order that I want it to be in. If I'm saying higher numbers are indicating more agreement or more support for this idea, versus lower numbers indicating not as much support for this idea, you need those sort of to be in the correct order. Another example, maybe a more cogent example, would be, well, x1, I guess, and we'll have a character vector. So we'll rank desserts. That's a good example. Pie, cake, and ice cream, right? So I want this to be a factor with levels where one is greater than the other is greater than the other, right? So I would make x1 a factor, and I'm going to reassign x1, which is the thing I already have here. I'm overwriting it with itself, but as a factor, right? And I can determine the levels. So despite the order being pie, cake, ice cream, it's pretty clear to everyone that ice cream is the best dessert. And then it goes pie, and then it goes cake, obviously. Not an opinion whatsoever, right? And then I can look at the levels of x1, and it shows them in order. And this works even if I have multiple of these things, right? So if let's do x2. Right? And then we're going to make x2 a factor x2 with levels the same as up here. I'm just gonna make it the same. Right, and then look at the levels. It's just going to give us the 3, right? Because it doesn't matter if there's multiple, right? Let's see, Steve put a comment in. Yes. So here, if we, so the first element of x2, the vector that we're turning into a factor here is pi. The second one is cake. So according to our levels that we've put in, we can now say x2, 1, right? So that's going to be pi. And look at x2, 2, it's going to be cake, right? So we can say x2, 1 greater than x2, 2. Oh. Okay, we gotta turn it into a number in order to do that, I guess. So we gotta cast it again, because in order for it to do logical operations, it needs to be a number. Right, yeah. So that's, wait, that doesn't make sense. Or does that make sense? Wait, what did I set up? I set up, it should be pi is greater than cake. Oh no. Wait. Two, three. Oh. This is why I shouldn't come up with examples on the fly. Yeah. Right. So you're setting up the value. So you see here when I set it as numeric, right? I've set up some order, and I think it's ice cream should be. Oh, okay. Yeah. So that makes sense. So I was thinking about it in terms of ice cream is better, but what this is really doing is saying, so when I turn now x2 into an, as numeric, and I print it out down here, the value that's first in this list is going to be 1, right? And it knows that the third element, ice cream, is 1 because that's the first factor level. And then the second one is 2, and the third one is 3, right? I mean, that makes sense. So we're assigning kind of numerical values to. So if this was not ice cream and instead was, we'll make x3, approve. Let's say it's just approve and disapprove, right? And so we want x3 to be a factor. With the levels, and it sort of makes sense to us to make disapprove 0 because that's sort of a negative thing, right? I mean, you can make it the opposite, right? But we're just assigning numbers to, we're assigning numbers to like words, pretty much, like to kind of scale them and order them, right? And R needs to interpret it as numbers in order to plot it. So this ties back to plotting, I swear. So we would want to set the levels to be disapprove, then approve, right? Because we want to logically think of approve as 1, or as 2, and disapprove as 1, right? And then maybe if you wanted to turn this into a binary variable, you would just say x3 is x3 minus 1, which, if we recall, is taking the vector and just subtracting 1. Okay, wait, yeah. So we have to do that before we make it a factor. Oh, no. Wait, no, we would want to make it as numeric, right, in order to do math to it. Yeah. Oh. didn't work. So we turn it to numeric. This is what we want. So there's a vector, and then it turns into a factor, and we turn it into numbers, and it has the right numbers that we want, but we want to turn it into sort of a binary 1-0 variable, so then we subtract 1 from it, right? Because we recall, so then if we print out x3, it's 1 and 0 for approve, then disapprove, right? And then we can histogram that, right? Tying it back, we're just going to set data to null. Actually, no, we'll set data to x3. What am I doing? Really simple data set. In fact, it's not a data set, so that might not actually work. Another sort of casting thing is as data frame, right? So now x3, that's how we kind of turn, you know, stuff like this into data frames. This is a really roundabout way of getting at this idea of just thinking about ordered things. But this will be probably pertinent to whatever data sets you're using, because it's really important in political science to think about these ordered variables. Kind of calls back to the 301 idea of ordered variables. So yeah. So we'll create a geom underscore hist. And I think this will work. Oh wait. Now we just need to, because we already declared the data set, so we don't need to do that. Yeah. So this is a really dumb histogram because it's just binary variable, right? But it gets the idea. If we, if this was a more of a dense data set, you know what I mean? It would make a little bit more sense. So if we just added some stuff to it, add some values. All right. We're gonna put a comma between those. There we go, do all the same stuff. And then do the same plot. That's a little bit more meaningful, but even then it's not really, but this is just an example I'm making up on the fly. So the really important part is sort of understanding the casting thing. And I think maybe some exercises with that will help us understand how the sort of mechanics of this work. But I'll go over this starting from line 42 again. So we have this vector of character variables, right? So cool, we have character variables. You can see this in the top right. I would keep up in the top right, and this is kind of how you can see the updated changes going on. Then we turn this into a factor with 2 levels, and it's logical for us to make disapprove less because we want to think of that as a lower value, disapproval as a lower value, and approval as a higher value. Just because that's how it's going to make sense to us. And like I said, you can do it opposite, but it's sort of best practice to make it sort of a negative thing. Disapproval is negative and sad, but approval is happy, so we make it higher value. I don't know. So then we set it as, we're making this a factor with 2 levels, disapprove and approve. Disapprove being first, so it's a lower value, but it's by default set as 1 and 2. So we would rather it be 0 and 1 so that we can make it a binary variable. So it's like either you approve or don't, right? That's kind of the idea there. So we turn it to numeric so that we can do math to it. So then if we printed it off here, it's 2 1 2 2 2 2 2 1 1, which makes sense of how I ordered it up here. And it's a numeric, so now we can do math to it. So we're going to subtract it by 1, and then when we print it off, right? Because that's how doing the math operators on a vector works. We just put the object name, the math operator, and then what we want to do, and then do the math with it, and it's going to affect every individual place in the vector, right? So I'm subtracting 1 to every place when I do this. I'm subtracting 1 at every spot in the vector, right? So 2 is going to become 1, 1 is going to become 0. I hope that makes sense. That's kind of a callback to when we were initially looking at stuff. Yes, right, Stephen. And yeah, and this is a dummy variable. I don't know if you talked about it with that name, the binary variable, the dummy variable. So yeah. And then we're going to turn it into a data frame. This is a really simple data frame, and you see it's moved up to data here. So it's just it's a 1x9 data frame, really simple. Usually you'd have a ton of stuff, like if we look at the GSS, right? And you can plot particular columns of some data frame, but this is just a simple example. And then we can plot a histogram, which sort of gives us a count. That makes sense to everyone. That kind of went into something I wasn't thinking we would get into, but I think that's really valuable. I think it's gonna be really valuable for if you want to look at if you want to visualize and kind of analyze survey data, which is often really interesting, kind of behavior type data. That's kind of what I'm really into, is the American political behavior. So that's really cool. Maybe less useful for Stephen because you got more nice continuous variables, GDP, stuff like that. That is nicer. But like you were also saying, using dummy variables, controlling for things, that kind of gets into more of the regression stuff that we'll look at later. But yeah, I think that's helpful. I'll write up a more cogent sort of walkthrough type thing with this concept. I think this is a good concept to go over and relates to plotting, but and sort of does the way I set up this, we did histograms before, so does the way I set up this ggplot thing make sense? I set the data set to be x3, and then sort of looking at the structure of x3, it has one column that's called x3. So I set the data to be equal to x3, and then this would be x equals x3, right? The x-axis. That's what's going on here. And I could scale this x-axis to look nicer, but I don't want to do that right now. So, yeah, I'm thinking we kind of were looking at this plot, and then we kind of sort of transitioned to this whole ordinal thing. I think both of these are valuable. I will make an assignment for next week. It will be pretty easy going for this, kind of covering both of these. I think I'll make a plot and put it in, and then you can look at it and try and parse and replicate it with code, right? It kind of goes to the idea of sort of, I have this picture in my head and I know what I want to plot, but I got to make it real with the code, right? And kind of sort of reviews the sort of simple ggplot stuff that we're going over, which I think is kind of all we're going to do. And then sort of looking at this ordered thing, I'll maybe have you format and factorize, turn into a factor some string variable. I'll find a cool data set for that. I think that'll be good. I hope that sounds good to everyone, and I hope that wasn't a complete mess. So, cool. I'm gonna stop sharing my screen now. I think that's enough for the day. Let's see. I'll stop. Cool. Okay. Any questions for me? Any questions about what the final project would look like? I think final project is a really strong phrase for what it's going to be. I think it's just going to be a fun thing. I hope you guys think this is fun. I think it's fun. So you pick something you're interested in. Hopefully you have interests. So yeah, I think it'd be a good time. And we plot something you like. Look at, maybe do some data analysis on something you like. And then you can say you've done data analysis, and that's pretty cool, especially for a philosophy major, Mason. It's pretty good.
Oh yeah. Hey, you want to talk, okay?
Oh, no. Called out. Okay. Yeah. Okay. Cool. I will be available, I think, on Friday. Exciting news! I'm getting an iPad tomorrow. I'm really excited, so I'm going to be playing with that a lot. But I'm down to meet and talk about stuff if you're still struggling. Yeah, Friday. Oh, what have I done? Yeah, Friday afternoon. I'll put it up. I feel like I'm not being I'm not having good enough communication about when I'm having office hours. I'll like mention it briefly. And I feel like kind of talking through this stuff and working through this stuff sort of in a let's work on something context is really valuable. I know that I always find that really valuable when I'm learning something new, like in this realm. So I think, yeah, I'll do 12 to 1. And I'm saying that now, but I'm also going to send out an announcement about it, I promise. So yeah, if y'all wanted to work together on something, or maybe the assignment that I make, hopefully tonight, depending on how fast I do my stats homework. It's due at 5, so I'll finish it by 5, and then I'll make the assignment, and then we can work through it on Friday if anyone wants to do that. Anyone watching the video or anything, and I'll send out an announcement about it. But yeah, of course. Okay, so I think we're good there. If there are no final burning questions, yeah, I think we'll work together on Friday. I think that'll be fun. We'll do some stuff. So yeah, I'm gonna sign off now. So thank you all for a good day, I guess.
Swag. Thank you, Zach.
Swag money. Stop.